Okay, so I just want to do a run through of integration of the logs and exponential. So basically, if you integrate e to the ax plus b, this is the most general form, you get 1 on a, e to the ax plus b plus c. So you're dividing by the derivative of what's on top. Reason being is because when you differentiated, the derivative would have been a. There should have really technically been an a there. Because there wasn't, then it's been divided out. And that's where that 1 on a actually comes from. Yeah. Basically, this is the rule that is on the formula sheet, so it's important to be familiar with it and to use it. You've got to create the derivative of f dash x there if it is missing. And when you do that, then you just get f of x plus c. Notice the f dash x disappears because when you differentiate it pops out and you times by f dash x. But when you integrate, think of it as popping back in. And it's going back to what the original function was before the f dash x was multiplied by. Okay, so now if you're asked to integrate, say, 2x plus 1 dx, then you would go 1 on 2 e to the 2x plus 1. Okay, if it is 7 over e to the 5x minus 1 dx, then you're going to have to bring that up to the top. So it's 5x minus 1, like that, dx. So the 7 can come out, and that's e to the minus 5x plus 1 dx. So when you do integrate that, you get 7. You have to divide by minus 5, e to the minus 5x plus 1 plus c. Okay. Now, if you are asked to integrate something like this, the derivative of what's inside is now out there. So you can't use the chain rule. You can't just divide by an e to the x, because an e to the x is a variable. So the key to doing something like this is to expand it. If you expand it, you can do it the quick way, or you could do it the long way. Just be aware, I'm just going to do it the long way just to make you aware of something. When you go e to the x times e to the x, and you get e to the x squared, or you get e to the x times e to the x, you're adding the indices, so it's e to the 2x, or multiply them when you have the brackets. E to the minus x all squared would be e to the minus 2x. Okay, so, and if you did e to the x, because the middle term will be 2 times e to the x, e to the minus 2x, that'll be 2 times e to the x, and if you add those indices, you actually get 0. So it's 2e to the 0, which is 2 times 1, which is 2. Okay, so let's go for it now. So it's just going to expand first, then integrate. So e to the x times e to the x is e to the 2x, because it's e to the x plus x, which is 2x. E to the x times e to the minus x is e to the x plus minus x, which is e to the 0. E to the minus x times e to the x, e to the minus x times e to, you have to add the indices, so that's going to be plus x, which will give you 0. And e to the minus x times e to the minus x, so e to the minus x times e to the minus x, that will give you e to the minus 2x, because minus x is 2x. So you've got e to the 2x plus e to the 0 plus e to the 0 plus e to the minus 2x dx, which is 1 on 2 e to the 2x plus 1 plus e to the minus 1 on 2 e to the 2x, okay, plus c. So it's a half e to the 2x plus 2 minus a half e to the minus 2x plus c. Okay, now just an integration where we have boundaries, and I just want to make one of your boundaries a lin boundary. So when you integrate that, you get a half e to the 2x, and you go from lin 2 to lin 3. So that's a half e to the 2 lin 3 minus a half e to the 2 lin 2. Now you can just chuck all that in your calculator, but 2 lin 3, I just want to show you how to do that without the calculator, If you pull that 2 up there, then you get half to the e to the ln 3 squared minus e to the ln 2 squared, which is a half. Now, e to the ln 3 squared is just 3 squared, because remember, e to the ln a is just a. They just cancel each other out, so you just get what's there. Now, that will then be minus 2 squared, because e to the ln 2 squared is 2 squared. So it's a half times 9 minus 4, so it's a half times 5, which is 2.5. Alright, so just with integration, so integration of logs, if you've got f dash x on f of x dx, that's just going to be ln of f of x plus c. Okay, now, so when you integrate that, the 3 can come out the front, because if you're looking at f dash x, the thing that is missing here is, because that derivative of x squared is 2x, so it needs to be 2. So it's 3 on 2 ln x plus 1 plus c. Okay, so the 5 comes out the front here. Derivative of x cubed minus 1 is a 3. So that means that in front of here we need a 3. If we put a 3 in, we have to divide it out. So it's 5 over 3 ln x3 minus 1 plus c. Okay, this one here, this is cos x on sin x dx. Now that is in the form of f dash x on f of x. So remember, with cot, cos is on top, and tan, sine is on top. If you want to get a tan, you go in the sun and put your cos's on the bottom. Okay, so the integral of cos on sine, that will just be ln sine x plus c. The integral of tan, now the derivative of cos is minus sine, so then it's a minus, so it's minus ln cos x plus c. When we're looking at this one here, e to the x on e to the x plus 1, derivative of e to the x plus 1 is e to the x, so that one's ready to go. It's just log of e to the x plus 1 plus c. And when we look at this one here, derivative of sine x plus cos x, actually you can't integrate that. It needs to be cos, needs to be, you need to have a different derivative, so we'll just switch that. It should have been cos x minus sine x. And if you have that, then you can go directly into ln of the bottom. Now, before I finish, I just want to go through one more thing. The one thing is just getting the difference between what's a log and what's a function to a power. Okay, so if you look at this, okay, for it to be a log, it has to be a power of 1, because the rule is f dash x on f of x. When it is a function to a power, the power here is bigger than 1, okay? And this one here, this is where you'd need to raise it to the top and get minus 4. And then it will be in this form here, f of dash x to the n dx. The only difference is that that n, the only thing is that n will be negative, okay? So just look for the power of 1, and if you do go to bring it up to the top, look what happens. If you go to bring it up to the top, not realizing it's a log, when you go to add the indice, when you go to add, you get 0. And if you get 0, then you can't possibly use function to a power, because it'd equal 1, and then it would disappear. Okay, so let's just look at both of these. So this one here, the 3's in the way, so that's x on x squared plus 1 dx. It is a power of 1, so it's a log. The derivative is 2, so put it over 2. So it's 3 over 2 ln x squared plus 1 plus c. Okay, this one here, bring the 3 out, so that's x squared plus 1 to the minus 4 dx. The derivative of x squared plus 1 is 2, so put over 2. 3 over 2. Add 1 to the power, which is minus 3. And divide by it. So it's 3 over 2, x squared plus 1 to the minus 3 on minus 3. This 3 will cancel with that 3. That minus just times the 2, which is minus, but overall it'll be a minus, because plus on top, minus on the bottom. So overall a minus. And then that's going to be x squared plus 1 to the 3 plus c. Now, I think I'll just extend you a little bit more just on with logs, because I just want to remind you of something, which I know it's probably easy to forget. If you want to find, say, this area here, and you've been given a log, so that's the area with the y-axis, okay? And if you want that area and it's up to ln 3, the reason ln 3 is because when I put 3 into here, I get into the function, I get ln 3. That function, by the way, I haven't done that real well, it's ln x, okay? So if I wanted to do that, then the area is the integral of x dy, because it's with the y-axis from 0 to ln 3. Now, I have x there, but I want to integrate with respect to y. So you've got to take your original function, which is this one, so it's log e of x, and then you go log e of x equals y, and then you just go e to the y equals x. So you've got to get x in terms of y, so then you can go the integral of 0 to ln 3 of e to the y dy. Now the integral of e to the y is e to the y divided by 1 from 0 to ln 3. So it's e to the ln 3 minus e to the 0. E to the ln 3 is 3. 3 minus e to the 0 is 1 is equal to 2. And just something that is a little bit harder than that. Let's do y equals ln. Let's do x minus 2. Mainly because then we're going to shift it 2 to the right. The asymptote will also shift. That's that one. Now, if we actually just want this area here, and that went up to 4, then if I want that area there, we don't know a rule for integrating the log like that. So what we can do is we can bring that back here to here, and see that will be ln 4 minus 2 is 2. So that will be ln 2. Okay. So if I actually want this area here, in here, I want to get this area in here because it's going to help me get this yellow area here. So basically what we're going to do is we're going to use this rectangle, find that area, and then you're going to take away that area there, the red area. Okay, so let's go. The area of the rectangle, we'll call that area 1, would be 4, because that's the width, times the height, ln 2. So that's 4 ln 2. And area 2, I'm going to make that one the red one, that area would be the integral from 0 to ln 2 of x dy. But I need to get x in terms of y. So I need to go to my ln function, which is x minus 2, which equals y, and make it log e x minus 2 equals y. Then I use my 7th rule. So I get x minus 2 is e to the y. X equals e to the y plus 2. That's what I need to integrate. So it's going to be 0 to ln 2, e to the y plus 2 dy. And then I need to integrate that. So integrating that, we get e to the y, because its derivative, that's 1. So you put over 1, so that's kind of pointless. So it's just going to be e to the y plus 2y, and I'm going to go from 0 to ln 2. So it's e to the ln 2 plus 2 ln 2 minus e to the 0 plus 2 times 0, which is e to the ln 2 is 2 plus 2 ln 2 minus e to the 0 is 1, be 3 plus 2 ln 2. Oh, not 3, sorry, 1. Because 2 minus 1 is 1. Now, that there is just the red area. So that's just the red area. So when I want to get the whole area, what I need to do is I need to subtract them. So I'm just going to do it here. We do area 1 minus area 2. So we do the rectangle, which is 4 ln 2, and we take away 1 plus, let me get rid of that. So we take away 1 plus 2 ln 2. So when you take away that, that's 4 ln 2 minus 1 minus 2 ln 2. 4 ln 2 minus 2 ln 2 is 2 ln 2. So end up with 2 ln 2 units squared.